This is lesson 7 of the quantum mechanics mini lecture series, Planck's work part 2. I'm going to write down Planck's formula that he came up with once again. I'll write it in a slightly, actually I'll write it like this. As before. Okay, so he was relating the energy of a black body, the energy of a black body spectrum to the frequency. Okay, the black body radiation as measured from a cavity. Now, the C1 and C2 terms, these are just numbers. They're just constants that he made to fit the experimental data, okay, the graph. And he took C2 to equal a very small number, 6.62 roughly times 10 to the minus 34 joule seconds. Okay, just a measure of energy per second. Okay, energy is measured in joules. A very small number, 10 to the minus 34. So extremely tiny. It's basically 0.33 zeros here, which I'm not going to write, 662. Okay, it's also given the symbol H, and that's known as Planck's constant. It's now called Planck's constant in his honor. An extremely small number. And as such, the implication of this, okay, in his formula, is that matter, okay, stuff, so let's say, you know, the cavity itself, the cavity walls, could only absorb or emit BBR, black body radiation, energy of some particular frequency f in multiples of HF. Okay, C2 up here is just H, and F is up there as well with it, HF. You can only absorb or emit radiation in units of HF. So in other words, E is equal to HF. Okay, E is energy in joules, H is Planck's constant, joules seconds, frequency in hertz, or sometimes even seconds, but typically hertz. So in other words, energy is discrete. It's discontinuous. A black body, let's say the oscillators, the electric oscillators, which make up the cavity walls. So remember, atoms, nothing was known about atoms in 1900, just before 1900. So it was assumed that there were oscillators, things which vibrate when they receive energy. And they can only absorb energy, these oscillators, in units of HF, okay? I should put an N at the front here of the HF. N is an integer. So N could be 1, 2, 3, etc., etc. So it can only absorb HF and not half an HF or 3/4 of an HF. HF could be 2HF, 3HF, dot, 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 dot. Okay, and Planck called these energy quanta. Energy quanta. Okay, the HF units, the HF, think of them like little chunks, okay? Think of light as a wave, and then if you zoom in, you'll find that it's made of these chunks, these quanta, HF. Okay, a very significant result that kickstarted the quantum revolution in 1900 when Planck presented this at the seminar at the University of Berlin. Okay, so electromagnetic radiation can only be absorbed or emitted by oscillators in a black body cavity in very specific chunks called quanta, energy quanta.